learn about what are the various processes in FortiGate, how traffic is handled and by which process, what are the different processes in proxy and flow mode. During a recent investigation with one of my customers, I was in a thought why the CPU is going high. And after all this investigation, I could figure out this is actually happening because of an process called IPS Engine. So I thought, let me provide a detailed information about how the processes are handling the various traffic, how CPU is correlated with the traffic, which process is responsible for what task. So thinking about this investigation led to my creation of this content. As I told, the high CPU utilization by IPS Engine process, but changing the policy to proxy mode resolved the issue. And this raised the question how DNS is related to the IPS. Let's begin. Whenever check the various processes on FortiGate, you will be able to see or visualize all the processes that are currently in a running state or currently in a suspended state or any state. You can use the command diag-sys-stop. You are aware hopefully. So if you use diag sys-stop, so you will be able to see all the process that are currently running on the FortiGate. So basically this diag-sys-stop is just an abbreviation or shortcut similar to like any other vendor. So the full command is diagnose system and top. Okay, so when we use the command diagnose system top, you will be able to see all the process that are currently running. It is something like ps command on any Linux or any other system and or a task manager in Windows. Here it lists all the process that are running on FortiGate, and I am going to explain you the various important processes on the FortiGate. Some of the important process on a FortiGate are like I am listing here: CMDB server, WAD, HTTPSD, FGFM, and there are many more. Let's discuss them in little detail. CMDB server, this is the process that handles the configuration database. So configuration database means whenever you are doing any changes on a FortiGate firewall, the CMDB server is responsible for the changes. So if there are like some ARP changes, routing changes, frequent routing changes with respect to the configuration, then also CMDB server comes into the picture. So whenever you will perform any configuration change on a FortiGate, you will see CMDB server utilization going high or increasing, or will be shown as a part of the list, and you will see because of this configuration change, this CMDB server is being utilized. The next process is WAD. WAD is like a Web Application Daemon, and this handles the web proxy services, SSL offloading, deep SSL inspection, and explicit proxy. It's not like some parts of explicit proxy, but most of the parts of the explicit proxy are handled by WAD. So this is also an important process. It's not important, but it's WAD is a very important process. Then we have HTTPSD daemon. This is for the web-based GUI of the FortiGate. So the admin interface of the FortiGate is handled by this, or even the API queries or API access. to the FortiGate. So this is also handled by HTTPSD. Then we have FGFM. FGFM process is like for the communication between the Forti manager and FortiGate firewalls. Any communication between FortiGate and Forti manager is being managed by the FGFM. More processes are like MIG-logd, Syslogd, FGT-logd, SNMPD. So these three processes are related to the logging mechanism on the FortiGate. MIG-logd is the one who is responsible for generating all the logs, kernel, like the main process for the logging. Then Syslogd and FGT-logd are the process who takes the logs from MIG-logd and then delivers to one of the destination. So if the log has to be sent to a Syslogd server, then the Syslogd process takes care of it. And if it has to be delivered to a Forti analyzer, then FGT-logd will take care.
The next important process here is IPS Engine. So let's discuss more deep into the IPS Engine, as this problem was more related to the IPS Engine process. IPS Engine process handles the intrusion prevention system functions. That means all the functions for verifying the IPS, like signature matching and inspection of all the traffic for any attacks based on the signature attacks, is handled by this process called IPS Engine. IPS Engine also handles application control. So if you see IPS Engine utilizing more CPU, that means you have to verify if you have application profile applied as well. IPS Engine also handles antivirus, web filter, DLP and other deep inspection functions. But here the point to note is if these profiles are in flow based mode. If the profile is in proxy mode, then this will be handled by the WAD process. Okay. DNS inspection only when DNS is being scanned as part of the flow based inspection, not normally. So it only comes if it is in flow mode. Okay. So if you use flow based security profiles and inspect DNS traffic and via IPS or web filter, so in such cases IPS Engine process is being used. So IPS Engine is responsible for IPS, application control, antivirus profile, web filter profile, DLP profile, and if DNS inspection, deep inspection is there on the deep DNS traffic. So you see here most of the time IPS engine is being used if it is in flow mode. Okay. Then we have WAD. WAD process mainly comes into the picture when your firewall is having proxy mode policies or it's running into explicit proxy. When it is explicit proxy, all the traffic being sent to the explicit proxy is clearly handled by WAD. Apart from proxy functions, WAD also handles SSL inspection, web filtering if the profile is into the proxy mode, and SSLVPN web mode. So one clear difference between the proxy mode and the flow mode is taken care by the IPS Engine, whereas proxy mode firewall policies are taken care by WAD.
After discussing about the WAD process, let's know about what WAD does not handle. I am listing here the type of traffic that is not handled by WAD. WAD means the process responsible for the proxy mode and explicit proxy, that is the WAD, Web Application Daemon. So these are some type of the traffic that are not handled by the WAD and they are taken care by different processes. For example, DNS traffic is taken care by DNS proxy, IPsec/SSLVPN is taken care by SSLVPND daemon, IKE daemon, IP based traffic like ICMP, SSH, or you can say SIP maybe, or uh, there are multiple protocols part of this. So they are handled directly by the session handlers, okay, or inspected by the IPS engine. So if you do config system session helper, then you will be able to see these session handlers. So under config system session helper, you will be able to see these system helpers which take care of other processes. Okay, config system session helper. Okay, then you have application controls. So application control is taken care by the IPS engine. Then custom UDP TCP services, non-proxied. So those are also taken care by IPS engine or in flow-based mode. Okay, so it's not flow-based engine. Flow-based engine itself is the IPS engine. So anything that is in flow-based is taken care by the IPS process. So I'm simply mentioning IPS engine or flow-based engine. Okay. So these are different types of traffic or tasks that are not handled by the Web Application Daemon or the web process. Coming to flow mode versus proxy mode. So the major difference, not difference, we are not talking about the differences in terms of the functionality of the mode, but as we are talking about the processes involved, which process is responsible. So here I am just telling the differences from a process perspective. So IP in flow mode, IPS engine handles the traffic in flow mode. Okay, while in proxy mode, web process handles traffic. So whenever you see a high utilization on your firewall on a FortiGate, you verify whether the CPU utilization is coming from the web or coming from the IPS engine. If that is IPS engine, then most probably it is due to the policy that is in flow mode or the traffic that is being handled by the flow mode. While if the high CPU utilization is because of the web, that means the policies handling the traffic are in proxy mode or explicit proxy, or the web filtering or the security profiles that you are applying are in the proxy mode or using the proxy features. This is the process difference between the flow mode and proxy mode. Coming back to my original reported problem, because of which all this started. So I had a high CPU utilization by IPS engine process, and I followed this troubleshooting steps to identify the issue. So first thing is verify whether the security policies are in flow mode or proxy mode. So as I can see, the utilization is from IPS engine. So mostly or my issue will be because of flow mode. Okay, so let's take down the responses from each point. From this I checked my policy is in flow mode. In my case it was in flow mode. Okay, in flow mode typically IPS engine uses more CPU compared to the proxy mode. WAD uses more CPU if in proxy mode, as I had explained in my previous explanation. Restart the IPS engine process and check if the CPU usage establishes. I tried this, and even after restarting the IPS engine process, there was no improvement. CPU of the device went lower for around 5-6 minutes, and then it was again started increasing, or it has again started increasing. So if you want to restart the IPS engine, you can use the fnsysctl command to kill the process, or you can use a command that is available or for specifically for IPS. So that is diag bit, okay, and we'll show you in the lab. So the command is diagnose test application IPS monitor 99. So 99 is the integer that tells the device to restart. I mean the IPS engine process to restart. Note, there may be a brief disruption to your service when you restart the IPS engine process. So kindly take maintenance window if you have so much of production traffic, or if it's okay, this will be just as like few seconds interruption, so 1 or 2 seconds, that's it. So if your organization can bear this, then it's okay even during the production hours. Then verify if there was any recent upgrade or changes related to the IPS engine. How you can do this? You can check the version of the IPS engine on your FortiGate and what was the version previously or when it was updated. If you use the command diag auto update version, you will be able to see what is the IPS engine version that you are running. Let me show you how to verify these things. Okay, so now I am on my device and let's just quickly show you how you can do these verifications. Okay, so for example, for the first point, verify whether the security policies are in flow mode. So you can simply show firewall policy or on the GUI. Okay, I don't have any firewall policy, sorry. Let me quickly make one firewall policy. Let me do this from GUI and show it to you. Okay, so here is my firewall. If I quickly create a firewall policy for your reference, okay, firewall policy, come create new, and it's like test policy, incoming interface, anything, source, anything. This is just for reference I'm showing, don't consider it as a real policy, I mean real traffic flow. Okay, so once you do this, enable create the policy, so you should be able to see this firewall policy, and it doesn't show anything here in the inspection mode, right? So when it doesn't show any options, that means the firewall policy is in flow mode, because the default behavior of FortiGate firewall policy is in flow mode. Okay, but if you want to change, okay, so firewall policy 1, so you see this policy in the CLI. Now if I make it config firewall policy edit 1 and I will say set inspection mode to proxy, I change the default, and now if I just do a refresh for the same policy, then you can see here the inspection mode, it is showing as flow based and proxy based. Okay, so this is how you can verify. If you don't see any option, that means it is in flow mode, and if it is showing this inspection mode, that means it is in proxy mode. That's why, because the default behavior is flow based and it doesn't show in the GUI. This you need to take care. Okay, that was our first point, how to verify. Coming back to our description, the next point I mentioned was how to restart to the IPS engine process. Okay, so when you want to restart the IPS engine process, you can simply use the command diag test application IPS monitor 99. So when you do 99, it shows restarting IPS monitor. Okay, so it will restart. And how you can verify, you can see under diag systop, the IPS helper process ID and IPS engine process ID will change. Okay, so restarting the IPS engine is diag test application IPS monitor and 99 you have to do to restart, and it will show you restarting engine. Okay, and the other way is also FNCTL kill, and then the process ID you can use to kill or the process. That is the other method. And diag test application IPS monitor, and then you can put a question mark. Okay, so to see what are the different options available under the IPS monitor, see toggle IPS engine information, bypass, restart, all these options are available under this command. Okay, check if there was any recent upgrade. For this you can use diag auto update versions, and under this command you should be able to see the uh, IPS engine version. So if you scroll it, IPS attack engine, okay, so the current installed version is 700548, which was updated when it was updated Wednesday 23rd 2353, like evening night. Okay, so this can also be verified by the system event logs. This is just how to check the IPS engine version, but this can verify it from the system event logs if there was an IPS engine upgrade. So you may try to downgrade the IPS engine if the issue started after a recent change or after a recent upgrade. Okay. Then inspect for any crash log related to IPS engine which could indicate the problem. So if you go onto the device and you have to do diag debug crash log read. So the diag debug crash log read, it shows all the crashes that happened because of some software bug or because of any memory issues. So whenever a process gets crashed because of XYZ reason, there is a crash log generated for this. And this crash log can be read using diag debug crash log read. So under this, if you see some crashes which are like recently or on your dates where you facing the high CPU, then you will get the which process is causing, or you may need to report an bug or contact Fortinet technical support because of the bug or why there is a crash log in this, to know the exact reason of the crash log. Okay, but in my case, even the crash, there was no crash logs, the policy was in flow mode. I tried restarting the IPS engine, still the issue did not fixed. So I verified for any changes in the traffic pattern. My traffic pattern was almost same the whole week, even yesterday. So this issue started after a recent upgrade of the firmware, but rest everything was good. There was no changes in the traffic pattern, all good. Okay, so this I verified. uh, then the next step was for me to identify the highly utilized policies. So by using the Forti analyzer, I was able to identify which of my policy is highly utilized, or even in the FortiGate we will be able to see the most data transfer or the transfer data bytes. Using that, maybe that will give you an idea, or you can use the FortiView sources on the FortiGate to identify the highly utilized policy. So I identified one of the policy which was highly utilized. I tried removing the security profiles onto that. So after removing individual security profiles like application monitor, IPS profile, DNS profile, web filtering, I have removed them one by one. And finally, when I removed the DNS filter profile, then the IPS engine CPU reduced to a very normal percentage. Then you have to like isolate the issue also by checking a failover or performing an failover attempt. If you perform an failover of the device and still you have the issue, that means the issue is not related to an individual device, instead it is with both the device. That means it's not hardware specific, right? That also you can isolate by doing a failover. So during this step, like when I was trying to isolate the security profiles one by one, I identified removing the DNS profile from the policy reduce the CPU utilization. Okay, so the solution finally what I gave was like I created a new policy only specific to DNS server and changed the specific policy to proxy mode, so the utilization shifts from IPS engine to the WED, and IPS engine will no longer have an high CPU utilization, and overall the CPU utilization will become normal. So what I did, I created a new policy for DNS, applied the DNS policy, everything, and then finally I changed the mode also to the proxy because this is only specific traffic, so that's not going to impact me. And I changed the mode so it
shifts from IPS to web process, and this is how I was able to figure out. Hope this troubleshooting scenario will help you to identifying some issues, to know more about the how IPS engine works, how web works, what are like the different processes responsible in uh, proxy mode and flow mode. Okay, we discussed so many processes, but there are some more process that we can discuss, like scan unity. Scan unity is for managing the antivirus scanning, and Forti sandboxing. This is like whenever you integrate with Forti sandbox. So there are so many other process, but these were the important ones that I discussed. Hope this will be helpful for you. Thank you guys. Thank you for watching.